Hello students, today we are going to talk about Max Planck's quantum theory. But before starting this lecture, make sure to like and subscribe to our channel. Max Planck's quantum theory, introduced in 1900, revolutionized our understanding of how energy is emitted and absorbed by matter. It marked the beginning of quantum mechanics and provided the foundation for later developments by physicists like Albert Einstein, Niels Bohr, and Werner Heisenberg. Let's see the key concepts of this theory. Planck proposed that energy is not continuous but rather quantized. This means energy is emitted or absorbed in discrete packets, called quanta or photons. He introduced a formula for the energy E of photons, given by energy of photon is equals to Planck's constant into frequency, where E is the energy of the photon, V is the frequency of the radiation, and H is Planck's constant, and the value is approx 6.63 times 10 raised to the power minus 34 joules. Let's check the significance of this theory. First, Planck's hypothesis of energy quantization was a radical departure from classical physics and laid the groundwork for the development of quantum mechanics. This new framework was essential for explaining various phenomena that classical physics could not, such as atomic and subatomic processes. Second, the introduction of Planck's constant H as a fundamental constant in nature provided a key parameter for quantum phenomena, influencing later theories and experiments in quantum mechanics. What are the impacts of this theory on future theories? First, in 1905, Albert Einstein used the concept of quantized energy to explain the photoelectric effect, further validating Planck's theory and earning him the Nobel Prize in Physics in 1921. Second, Niels Bohr used the idea of quantized energy levels to develop his model of the hydrogen atom in 1913, explaining atomic spectra. Third, Planck's theory was a precursor to the full development of quantum mechanics in the 1920s, with contributions from physicists such as Heisenberg, Schrödinger, and Dirac. That's it for today's video. Until next time, stay safe and keep experimenting.